All right, I'm gonna go ahead and get started. So welcome to the Atomic Red Team webinar. This talk is gonna be about how to scale and improve your testing. We've got a couple of guests with us today, which has got some really good content. So thanks for joining. Just a couple of housekeeping items. You will be in mute mode while we're doing the presentation. If you do have questions, please post them in the Q&A icon in the Zoom meeting, and Mike Haig will be fielding those questions. We do have questions along the way as we go through the webinar, so feel free to ask questions and we'll either address them at the time or we'll get to them at different points during the webinar. So we did have a few questions. A number of people that are new to Atomic Red Team asked about how to get started. So just a quick note, there's a great resource at redcanary.com/atomic-red-team. So you can check out that link if you want to get more information on background or get caught up with some of the things we've been working on with Atomic. So with that, let's go ahead and get started. Let me introduce our guests here. So my name is Casey Smith. I'm the Director of Applied Research here at Red Canary. You can connect with me on Twitter at @subT. I'll hand it over to Mike.
Hey, my name is Michael Haig. I work here at Red Canary as the Advanced Threat Detection and Research Director. So I work with Casey prominently, real close on Atomic Red Team and other projects.
I'm Brian Beyer, one of the founders of Red Canary and deep lover of all things YAML and Git, which is really the reason why I'm here today.
And I'm Blake Strom. I work for the MITRE Corporation, which is a nonprofit organization that works in the public interest. And I'm one of the original creators of the MITRE ATT&CK framework, and I'm also one of the leads of the CALDERA research project.
Super excited to have you, Blake. Thanks for being here. Okay, so let me go over what we're going to cover. So we're going to just briefly make sure everybody's up to speed on what Atomic Red Team is, how it ties into the work that Blake and his team are doing with MITRE ATT&CK. We've made quite a few changes with Atomic Red Team as far as structure and layout. We want to cover what those changes are, why we are working with YAML, how to generate the Markdown that a lot of you may be used to. We still have preserved that, so we want to make sure you understand how that's preserved and generated. Go over a workflow of how you would contribute and participate in the Atomic Red Team, and then we've got a lab, and then we've got an exciting opportunity for Blake to share some of the work with CALDERA about how they're using CALDERA to do automated testing that ties back to MITRE. So we're really excited to show you sort of a real-world example of someone that's doing some automation at scale. Pretty cool stuff. Okay, so we put together this diagram just to show you where things fit as we talk about different components. Remember that MITRE owns the ATT&CK framework. They are the creators of that, and we are really just building test cases off of this. And so really, we wanted to take the ATT&CK framework and create something that allowed people to test against that framework. And so that's what Atomic Red Team was really generated for. So how do you test these techniques, do an evaluation, try and identify where you may have gaps or coverage gaps in the framework, and then look at improving. So as MITRE continues to publish new techniques, you can ingest those into different frameworks, into your testing, and then the cycle continues. So this really sort of succinctly describes the Atomic universe as far as the way we see things sort of fitting together. So again, as far as what is Atomic Red Team, really it was the origin of it was to do some fundamental testing coverage to improve security. So everybody has gaps. There's a lot of moving parts when you deploy a security solution. So we want to make sure teams could test and evaluate those gaps. Testing should be fast and easy. And we always want defenders learning how adversaries are operating. So we really wanted to demystify a lot of the techniques that MITRE ATT&CK it has in their taxonomy. So make sure there's really no mystery around how the attack is conducted so you can test against it. Approachable for humans and machines. The machine part is something we just added. We're going to go over in detail today. So primarily up to this point, things were very manual and had to sort of copy and paste scripts. What we've done now is create some harnesses we'll get into to allow you to take a dependency on Atomic. That's pretty exciting. Documentation, again, all of the documentation links back to MITRE's taxonomy. And we really want this to be something that's open for the community to begin using and participating in. So in order to accommodate some of the community participation, we've actually created a Slack channel So I want to let Mike talk a little bit about how that Slack channel, how you can get started with that. So I'll turn it over to Mike for just a minute.
Awesome. Thanks, Casey. Yep. So we created a workspace. You can head on over to slack.atomicredteam.io and you just enter your email address. You'll receive a quick invite and you can hop right into Slack. We're also, everyone's in there. If you want to talk to Casey or I, we're available as well. Right now, it's very just open in the general channel to just talk about kind of anything free form. As things begin to progress, we'll start separating out different channels for everybody, depending on projects or different things people want to attack. No pun intended. And then from there, we also wanted to add a bit more to the community for wrapping everyone into Atomic Red Team. So on our next slide, we also created a new GitHub IO page, and it's just atomicredteam.io. And if you go to that page as well, we do have a join on Slack button here. This is mainly to allow for folks to go to, have a quick way to reference how to contribute, use cases, understand the philosophy of Atomic Red Team, go straight to GitHub, view all the repo, everything on there as well. So those are two of the bigger items that came out to allow for more community involvement, people interact with us, and get involved with the project as well.
Awesome.
So from here, I'm going to go ahead and pass over to Brian to talk about the third big change.
Yeah, so
let me jump to your slide, Brian, there. There you go.
So one of the things we realized as we saw Atomic Red Team taking off is that there was a huge amount of potential to start automating this, right? Atomic Red Team was very powerful because you could dive in, you could go to a page on GitHub, you could see a couple commands that you literally could copy and paste out of a GitHub Markdown page into your command prompt or PowerShell console. And in that simple of time, you've now just executed an attack technique. And so what we really learned quickly is that people want to do that very often. You know, some people are setting themselves calendar invites that, you know, every morning or every Friday, that's when they do their testing. They go pick a random technique, they go exercise that. And the first thing everyone thinks about after they do that for a couple of weeks is, how do I make that easier and how can I automate it? At the same time, you had some great projects like CALDERA, which we'll hear about later, Uber's Meta project from Chris Gates and team, and others who were all looking at this and saying, attack is this awesome taxonomy describing these techniques. Atomic Red Team describes how do I actually exercise them? How do I actually pull that all together with a machine? And so we had some discussions, really looked at what's possible, and chose YAML as the best way to describe it because it was really this unique mix of both machine readable as well as human readable. And so if you jump forward, we'll walk through a little bit of what this structure looks like. So on the next slide, what you'll see is a quick YAML 101. YAML is one of those languages that looks incredibly confusing when you first dive into it. Some of the subtleties of it aren't very obvious, but once you know the guidelines, it's extremely simple to do it. I mean, even Casey now loves YAML, has decided like he's not writing PowerShell scripts anymore. He's just going to completely write everything in YAML and XML style sheets. So he's completely evolved to the next level beyond all of us. So key things about YAML. If you're familiar with any language that has the concepts of maps or objects, like JavaScript, PowerShell obviously has them, Python, everything is all about being key value pairs. And so in this example on line 3, you can see, hey, we have a key who's named key1, and it has a value that's a string. Well, on line 4, we get one of the really neat, powerful things of YAML in that we can have multi-line strings. And so if you need to put a lot of detail, maybe you're writing up in an attack definition, hey, here's some tweets associated with this, here's some links to open source intel. The ability to have all of those lines all nicely formatted and wrapped is what makes this so good for being both human and machine readable. So highly recommend, obviously these slides will be posted afterward. There's lots of good resources on YAML and what the structure is. I'd say, you know, my 2 cents of the biggest recommendation or lessons learned are pretty common. 1, never use tabs, always use spaces. If you use spaces for everything and keep it consistent, life gets much easier. And 2, it may not seem obvious, but it's really important that you don't put a space before the colons. I think that was a bunch of the first things we learned internally as our team was getting spun up on this. The formatting of these actually matters quite a bit. Now, the great resource is there are lots of linting tools online. You can go to yamllint.org, you can copy and paste in your YAML file, and it'll actually check the syntax for you and make sure you structured things correctly. It's a nice format. It may look to you a little bit like JSON without curly braces. That actually is a good way to think about it. JSON and YAML actually are pretty able, it's pretty simple to mix back and forth between the two of them.
Awesome.
And so if we look at the structure of what these atomic tests now look like, we've tried to keep it really simple so it's easiest for everyone in the community to contribute. One thing you'll see is that we have one YAML file per attack technique. And in it, there's this header information at the top that links it back to MITRE's attack. And so you'll see you have the attack technique ID and you have the display name. So it's really easy to jump in a file if you haven't memorized that T1007 is system service discovery. And then at the bottom of that, the next bit is that we're going to have this array or this list of all of the atomic tests that are associated with this technique. You'll see up in the repository, some techniques have only 1 or 2 tests associated with them. Some of them have 7 or 8 or even more because we've got a lot of good ways to exercise them. And each of these tests has metadata about the test. So key things, obviously the name of what the test is exercising, the description, probably not a really good example here. Ideally, we'd do a better job of pointing back to open source intelligence or resources or why this is a good way to test. But then you can see there's a key of talking about what platforms are supported. This is how we can identify which tests work on Windows, which ones work on different variants of Linux, what works on Mac OS. And you'll note that all the possibilities here exactly match back to what MITRE uses in their attack and other, you know, CTI data that they've provided in their cyber threat intelligence framework.
Yeah, this is probably the biggest change, Brian, too. One of them was just really the structure. We used to have folders that had each operating system and then techniques underneath there. Now we've got really everything's linked by technique, and the operating system is just an attribute, which really helps with automation for sure. So
absolutely.
cool.
And it was really based on great feedback from the community saying, hey, the way that I can test this on Mac OS and Linux runs the same commands, has the same payloads. We'd love to not have to duplicate that over and over. And so this is a great way we can do it.
Awesome. Yeah, and we're going to touch on it a little bit later, but all of this is, Brian wrote some validation routines. So before we take a pull request and merge it, we have a way to validate to make sure that you've got everything structured right. And we'll go over some of that a little bit later. So if you don't get something right, you'll know what it is, where the errors might be before you actually submit a request to us. And we'll go over that in a little bit. So
exactly.
This is the big overhaul. The other thing probably maybe to point out is parameterizing things like on line 25, where you're making a service name a variable at this point that can then be patched in by some automation tool.
Exactly. And so what we viewed is that every one of these tests really has some way to execute it. And that execution in some cases is go run something on the Windows command prompt, or it might be running something inside PowerShell. There's actually some good examples up there that have to do with browser toolbars and extensions that actually have an executor that is manual, and it actually has a listed set of steps to go run through. You know, not everything's like that. Those will be rare exceptions, but this format allows you to support all of those.
Awesome.
And Brian, we also have, I'm on the GitHub repo, but all the input argument types are broken out, right, within the repo there?
Exactly. They're broken out in the docs, and they're also checked on the validation script. And that's something where definitely want to offer it up to everyone contributing. If you come across this common input argument type that isn't listed as one of the choices, that validation script and those docs are up on GitHub just like these tests. So add a new data type, submit it as a pull request, and we'd love to have that contributed in.
Yep. Awesome. Very cool. I'll jump to the next slide then, Brian.
Great.
Yep.
All right, so one of the things, like we said, that we absolutely wanted to maintain is that Atomic Red Team is well loved because you could go to a GitHub page, copy and paste commands, run them, and execute a test. And so we absolutely needed to maintain that. And so what actually happens now is that every time a YAML atomic test is committed to the repository and merged in, there is a automated build behind the scenes that goes and generates the Markdown document based on that YAML structure. And so you can see an example of what it looks like here. Something I'm really excited about. We actually are now able to pull in the actual description and metadata from attack, which now, thanks to Blake and the rest of the attack team, doesn't even need to hit the MediaWiki APIs. It's actually available via taxi, or in our case, we're actually hitting the cyber threat intelligence copy of that sits up on GitHub. And so that's how we're able to actually pull in all of the metadata from attack directly into these Markdown files. And so now you've got this single source of reference where you can read and learn about the actual attack technique, and then see a list of multiple atomic tests that you can run based on operating system to exercise it.
Yeah, that's great you guys were able to do that. So just for everyone's awareness, if you are pulling from the API on the wiki, it will be deprecated once we stand up the new website in a month or so. So we're looking at probably deprecating the wiki sometime in the September timeframe. So you've got plenty of time to move over.
Perfect.
And Blake,
Yeah,
that CPI format was awesome, having seen what our initial implementation was of trying to hit the MediaWiki API and parse out different structures and parts of it. That was tricky, but definitely worked. Now being able to hit this massive JSON document off of GitHub and parse and run from there is a great way to do it. And if anybody else has that need, I know a lot of you don't often work in Ruby, but if you need a Ruby API into all of that attack data, you can actually pull that directly from the Atomic Red Team repository. It's wide open and available for everyone.
Perfect. Yeah, that really helps sort of separate and make sure that the ownership is like MITRE really owns the techniques, the descriptions, the metadata. We're just taking dependency on it, which is really pretty awesome. So cool. I think at this point we've covered a lot of ground, so I think we wanted to just open it up. I don't know, Mike, if we have any questions on like things we've covered so far before we get into lab time. If we have a few minutes to take some questions if we need to.
Yeah, let's see. If anybody has any live questions here, I don't have any kind of laying around just yet.
Okay, that's fine.
What you eat. Yeah, I mean, we could always ask what you eat for breakfast, but we can leave that for later too.
Yeah.
I did see one in the chat from Tim asking, is the directory structure for the additional files necessary for some tests standardized? So are we going to put all the payload files in the source directory? I'll maybe chip in, Casey, Mike, maybe you guys have additional thoughts. One thing we wanted to do was make it so that all of the tests for a technique were very self-contained in that technique's directory. So if you have a payload for a test, that test or that payload and test together should all live in that same directory. So T1007, for example. If some of those payloads come with source code, so you maybe have some C code or C# code that needs to be compiled into the actual payload, what we've started to simplify or standardize those on is that source code lives in the SRC directory. And then there will be some way that we ideally want to make standards to say you're always going to have a build.bat or a build.sh entry point so that anyone can clone the repo and then just run that build script and it generates your DLL or payload for you.
Yeah, I think we're open to feedback on this one too. This is one of those areas where we want to be very transparent, so we don't want to just put binaries out there that run the test. We always want to make sure there's some source code that backs it. but we realize different teams have different, capabilities or skill sets. Some people will be able to compile or customize those. Some people just want to take a dependency on a DLL or a binary. So we'll go either way on that. But if you guys have feedback, that's great for like the Slack channel. If we need to restructure, this is something that has been working well so far, but we're open to your input. So, yep. Awesome. Okay. All right. I guess with no other questions in, we've got a bit to cover with our lab time. So really we wanted this to be very, demonstrate some of the capabilities for how to use and contribute. So we want to take you through how to use the Git commands to contribute. So a couple of things we'll take you through real quick. And then we'll wrap up with Blake talking after this lab about some things that they're doing with Caldera. So first of all, one of the things that you want to do is make sure you create your own clone of the Atomic repo. So you will need your own GitHub account, whether that's a corporate account or personal account. And this is where you can do your structuring and design the code or test the way you want them. Or if you're writing a new technique, that's what we're going to actually go through here is how would you build a technique where we have a coverage gap in our testing framework. So and just a reminder, if you really want to just consume Atomic, you can always just go to the GitHub repo and download the zip file too. So there's a lot of different ways to get the code. But what we're going to take you through is how would you build your own new technique. So the first thing you would do is just simply clone the repo into your directory, and then you would issue the checkout command, and you would basically give it some name for your branch describing what your test is going to be in this scenario. So pretty straightforward. I use the Git desktop. Some of you are maybe familiar with the Git command line, so we've just gone ahead and put the command line examples in here. So first thing you do, create your own custom copy of Atomic. Once you do that, you're going to want to generate a new test. Now, Brian wrote a really cool script that just basically copies a template for you. So you would just simply run the new Atomic Ruby file with the technique name and the situation, uppercase T, 1, 2, 3, 4. And then there you can then begin filling in the YAML. And always be sure if you get stuck, feel free to reference all the different types that are in the repo. We've got examples of tests with one test. We've got multiple tests, like RedSurf32, for example, has 3 different ways to execute the test. So feel free to look at other templates if you do get stuck, or reach out to us either on GitHub or through the Slack channel. So you create your task, pretty straightforward. After you've created your task, at this point, you're going to want to, this is really the heart of the new Atomic layout or the YAML format that Brian went over. You would simply describe the test and the different components here. Probably the most important things are things around input arguments. We got a lot of feedback that people wanted to customize this. And, as I look at like RedSurf32, for example, this technique, in this example, we have an input argument called URL, which then later is referenced on the command line with the pound and then the brackets and then the word URL. That's what you would substitute, for example, where your payload is. By default, we've just substituted like an example.com. You would want to rename that file to wherever you're pulling your payload from. Again, trying to be consistent with the Atomic repo. It's never really a good idea to pull down payloads from Git repos that you don't control. So that's why it's a good idea to clone and keep your own copy hosted somewhere when you're running it. But generally speaking, this is the flow that you would follow. Remember, there's other components here that can be changed. So attackers often rename system files. So they could very easily rename scrobj or redsurf32, for example. So be flexible, and we can make a lot of different changes down the road to some of these test cases to accommodate those adaptations that attackers might have. So at this point, you would then define, Brian went over some of this already with the structure, but you would have the Atomic Red team. All of our tests now live in the Atomics folder. You would have one folder for each technique, and we're really trying to leverage the structure and taxonomy that MITRE has already created so that you could then map back to that. You'd have one YAML file that describes all of the tests. Payloads would live here as well. And then Brian went over, if you have a binary or a source code, you would have a bin or a source path. And there's a couple examples on that. For example, like install util technique has some examples of separating the code and the DLL. So Now, this one is pretty interesting here because we have so many checks when you're checking in your code. Brian wrote an awesome validation routine. Now, the reality is that this is going to get validated by Circle CI, and Brian can probably speak to that in a little bit in more detail. But essentially, you could validate locally and also generate some documentation locally. But realize if you don't have Ruby on the system, the build when you submit your request to GitHub, it will do the validation for you. So, but just wanted to give you a chance here to run the validation routine before you actually submit, so you can make sure everything conforms to the templates that we've created. And that just makes things easier down the road, so you're not trying to troubleshoot a technique that has a bug or an extra tab or something that wasn't required. So this really helps us keep the integrity of Atomic. So now, this slide is actually for me because I'm terrible at Git. So Brian put together like the kindergarten GitHub like things to do. So for, at a high level, this is really like the 6 commands. Do not veer from these 6 commands. You don't need to do anything else with these things. Don't go buy a GitHub book or any of that stuff. Just stick with these commands.
Do you have your GitHub book sitting right in front of you?
I should. It's at home, but I did. I went out and bought a GitHub book, and I was like, look at all this stuff you can do. And Brian's like, no, you need these 6 commands. So
to be clear, this is not the kindergarten version of the training wheels version. These are the only 6 Git commands you ever need to know. If you
Fair enough. Yeah.
You can solve world hunger and world peace with Git.
Yeah, there you go.
You'll just never come back from it.
So anyway, yeah, we just wanted to put that in there as a reference for people because it's not something that I'm in every day. And so different people have different levels of experience. So this just kind of describes the process of checking out to committing and pushing your code up into GitHub. So there's additional resources referenced there. Git has some really good documentation if you want to learn this as well. So we don't want to make a full webinar on GitHub, but definitely something that you will need to know if you're going to contribute to Atomic. Yeah, I was gonna tell a story about like I was complaining to Mike Hague because I kept seeing these 2 dots at the top of every directory, and I thought Mike had committed 2 dot files, and it's just the directory structure. So I'm an idiot. You
were literally clicking them and wondering what's going on.
Yeah, pretty awesome. So don't be afraid to make mistakes on GitHub. You will definitely make mistakes. So again, once you've created your test, committed the test, and sent it up to your repo, then you will create the pull request. And that's where one of the maintainers like myself or Mike or Brian will take a look at it and make sure everything looks good. We'll run the test before we actually merge it in. And so this would be true not only of new techniques that you're creating, but also of bug fixes or things you want to add to enhance. Like maybe you want to add an additional test to a technique. This is a great way to participate in that. So. All right. Again, I kind of mentioned this already, but here's an example. We had like a PowerShell hook where we could do an API hook and just intercept SSL requests as testing the hooking technique 1179. You can see this is the flow after we've merged that in. So pretty straightforward stuff after you do it a couple times. But if you're new to it, feel free to reach out with questions if you're having any trouble getting something submitted or whatever.
Hey, Casey, this is a good question that came up related to payloads. And you mentioned a little bit about it, because I just want to reiterate it here if you can. Related to, would it be best for us to host our payloads in the actual technique directory, or would it be better to like host them, off of the Atomic repo to make the call like a PowerShell download call? What would be the best bet for any kind of downloads?
So I don't mind Atomic Red Team being the source for the payload description and binary, but when you're actually testing these on production, I think you want to host it on your own repo or somewhere else. But we definitely want the new style is the payload belongs in the technique directory. We used to have all the payloads broken out, and it didn't really scale well, and the feedback we got was now we're maintaining all these different directory structures. So we definitely want the payload for the technique in the folder with the technique, and then you can host that on your own repo, because you shouldn't really be running something off of a repo that you don't control. That's best practice. Does that answer the question?
Yeah.
Right.
So definitely. And go ahead, Brian.
From our perspective, Casey, we're okay with if people are hitting those payloads off of Atomic Red Team, right? Really, if there's
Sure.
any concerns with that, it probably comes from GitHub themselves more than anything.
Yeah.
It's just the best OPSEC practice. Don't run your payloads off of Sub-T's GitHub page because he is trolling you.
Yep. And yeah, exactly. Yeah. Too many opportunities for something to be inserted there incorrectly. But yeah, we're okay running it off of our repo. All the tests are really pretty benign. Honestly, there's not really, they're all to test coverage, not necessarily be used to do an actual attack. So, and then this was the best icon I could find for Circle CI. It's an enigma to me, so I'm going to let Brian talk to Circle CI a little bit. Basically, if I get the green check mark, I'm super happy that everything passed when I check in my code. So maybe, Brian, you could give a little background on why Circle CI is a important new addition.
Absolutely. So one thing we've learned, and I think the Facebook guys in particular have done a really good job with the OS Query open source project. So big thanks to them. We've learned a lot from them about how to make it a good community that everybody can get involved with. Two big things that you want to have is it's really easy to clone the repo and start contributing. And so that's why good documentation is key. And then make it really easy to be able to land a pull request. And one of the best things we can do is give all of you and all of us really good feedback about the quality of what we've done. It'll burn people out if you're doing code reviews and trying to figure out, hey, how's that YAML file messed up, or why doesn't it work anymore? And so that's where we can use platforms like Circle CI, who really just automatically run these tests for us. And so what you'll see is when you submit a pull request into Atomic Red Team, in your actual pull request, there will be this little section that says Circle CI is running your tests. And so that's where Circle CI is going through and validating all the scripts. And it'll tell you, hey, something's wrong with what you contributed. That's actually, really, we created it for ourselves. We did this conversion from Markdown to YAML in about 2 weeks, and we needed something to help us make sure that was done in pretty good quality. And so Circle CI does that for us as well. So you'll see it. It'll be very, it'll be at the front of things with either big green check marks or big red X's in case something goes wrong.
Yep. And I guess the thing there is that's not something you need to download or put on your machine. That's all server-side validation as things are coming into the repo, right?
Yes.
Yeah, Circle CI is not a local thing. You don't need to do anything with that other than it just really puts a nice fence around the project to make sure we're not ingesting something that breaks other things.
Yep, exactly.
Cool.
It's a helper service who runs stuff for us behind the scenes.
Yep, and this is good because this is something that I learned just around like quality of code and things like that. I think Mike and I both really learned from Brian about how to make sure this integrity is good because as more and more people start using Atomic, we quality is very important to us, and so this is that piece that gives us that strong foundation. So thanks for all their help on that. It's pretty awesome.
And we'd love everyone's feedback on this. I know we've gotten some great pull requests coming in that identified in cases where we defined arguments inside some of the commands that used the dollar curly brace syntax instead of the hash curly brace syntax. That's the type of thing where, hey, if you want an awesome first thing to dive into and either know some Ruby or want to learn a little bit, update the validation script to look for those wrong forms of syntax. It's kind of a tough problem, but if you can do that, it's a great thing to add in.
Yep. Cool. So those are, I don't know, we've got a couple of minutes here before I turn it over to Blake. Are there any questions, Mike, on the process of contributing, creating new techniques? Legitimate questions, not troll questions.
Let me get past the troll ones then. Actually, a really good question. Got a really good one, I think, here. So the question goes to, when you execute commands, could the commands be dependent upon the previous command's return value? So like, how we create the list of commands, if you're looking for a value of like the username, could the next command use that username? It's actually something I didn't think about.
Yeah, actually, it's a good question. Yeah, it's a good question. And the way we would handle that right now would be within the test harness yourself. So like, let's say you're running the test in PowerShell, then you would stash whatever output into a variable. and then take that, consume that variable in the next step. That's something that we're working on, is having a little bit more formalized like harness or execution framework that's a part of Atomic. But right now it would be up to you as a tester to take those variables and consume them. Like it could be as simple as it's a batch file that writes the output, standard output to a file. The next command reads that file and processes through like the list of IP addresses or whatever. But right now that's really on you as a testing team to handle output and input that's dependent in your environment. So I think that answers the question. So that's a good question.
Casey, do you remember, now we're going to see if you actually have memorized all the techniques. Do you remember which technique is the creation of a certificate authority? Or maybe Blake, you remember the name?
I don't remember that one.
I know there's something in there, but I don't remember off the top of my head.
We can find that and send that out, or maybe I'll browse through it as Blake presents here. There's one of these that is a great example for how complex the commands can be. And so there's actually this test about creating a certificate authority that runs inside of Bash and has if conditions inside of it where it's checking what operating system it's running on, because the commands to install a CA are different on Red Hat 6 versus, or I guess CentOS 6 versus CentOS 7.
Yeah.
And so
the
best way to imagine that list of commands is really any script that you could paste into a bash file or a Windows command prompt file and run from there. Bingo. Katie with the save. T1130.
Perfect. Yep. I just had it queued up. Yep. So yeah, that's a good example of a test that has that kind of flexibility in it. Let me see if I can just bring it up real quick, Brian, and show it before we turn it over to.
And so to answer the question there, what you can see is you can absolutely share the results of each command inside of that greater command block, because you should imagine this just like if you were running any batch script or any bash prompt. So you can, use variables, you can set variables, interact back and forth. This is just like if you were running a script on the target system.
Yep. Cool. Good questions. Awesome. So one of the things that we wanted to do with automation was really let Blake and his team share a little bit about some of the things they've done with the CALDERA project. So at this point, we're going to shift gears just a little bit to give you a sense of like what's possible with these types of frameworks that perform these tests. So I'll go ahead and turn it over to Blake to share some of the awesome work that his team has done with CALDERA and the testing of the MITRE framework. So I'll turn it over to you, Blake. Just let me know when you want me to advance slides.
Sure. Thanks, Casey. Go to the next slide.
Okay.
Yeah, so there's really no denying it. Automation is an important part of testing and verifying defenses. But one of the good things that makes it useful is you need a good language and framework. So everybody needs to speak the common language. Then it needs to be interoperability between tools. So efforts like OWASP, OVAL, and CVE have been useful for vulnerability scanning, but nothing really existed before attack to document how attackers are behaving post-exploit. Endpoint data collection and detection analytics or mitigations are sort of a different beast than scanning for vulnerabilities, because it isn't always clear what the risk is and how to deal with it. So after all, a lot of this activity is just how attackers leverage what's already there to do bad stuff. Attack was really built with this in mind. We were using it to plan adversary emulation scenarios, to test the effectiveness of endpoint sensors and behavioral detection analytics as attack was being built and refined. So it's kind of baked into there. The defense could then map to what was detected based on attack, and then we were essentially using that as a measuring stick to show progress over the course of multiple exercises. It was important, of course, to test chains of activity that are realistic to how an adversary would normally act. So how they're discovering new information, using that information to move around. It was a long and tedious process. I'm sure a lot of you have felt this. And it was also a drain on the red team because they keep having to perform similar actions to verify things as they were going, and when they really wanted to tackle harder problems. So this was a lot of the motivation that drove us to start working on the CALDERA project. Next slide.
Yep.
So CALDERA is a research project that started at MITRE a couple of years ago in MITRE's internal R&D program. So it's the same place ATT&CK came from. And its purpose was to automate aspects of adversary emulation, which is essentially threat-driven red team. So you're combining threat intelligence to drive the operations and the techniques that the red team uses so that they mimic or behave like a threat that that organization typically faces. So the approach we took was essentially made it the research project was to attempt tackling the problem of how to automate intrusion behavior in an intelligent and autonomous way. So CALDERA isn't just a script that implements various attack techniques. We've actually created a way of describing attack-based TTPs with logic. So things like prologue. So the system can understand when it can use a technique and what it gets out of performing it, which allows it to chain together actions into a sequence and use information from one technique, like discovering a host name, to drive use of other techniques, like moving laterally to that specific system. Next slide.
Yep.
So to make CALDERA work, we developed what's called an online planning system to drive its actions. And planning is a branch of artificial intelligence, just to get my buzzword quota for the day. CALDERA essentially does this by keeping an internal model to track what it knows about the environment. So think Windows systems, Windows domains, and the set of actions that it can perform in that environment. And that's the attack representation. We've defined the actions with preconditions, which are essentially the requirements to do something, and postconditions, which are the results of taking an action. That could be either learning new information or gaining new access. A simple example is based on dummy credentials. So you need elevated access to do it, and then you get accounts and passwords as a result, which can be then used to drive other techniques. The system essentially generates a bunch of plans at each step and chooses the best plan with the highest expected return on value, and then performs the first action in that plan sequence. So in the example on the slide, if CALDERA wants to copy a file to a remote system, this is one plan that it may generate. So it dumps credentials, uses those credentials to mount a share, and then copies the file through the mounted share. But what makes this an online planner is that CALDERA updates its knowledge and replans to find the next best action at each step. So back to the example, if it dumps credentials, and because that's the next best action and doesn't get what it needs, it may decide to then backtrack, find another system, dump credentials there, and then look for the appropriate access to reach its goal.
Are those plans something that like the community can contribute to as well, Blake? Or is that something that is just generated as the system is doing its discovery and carrying out the actions?
Yeah, it's all generated as the system's doing the discovery. So
Got it, okay.
if you take a scripted approach, you could define a set of sequence of actions, and it's essentially like an if-then,
Okay.
and then it's just continuing to loop
Awesome.
through certain conditions. But in this implementation, you define the technique and what the technique needs and what it results in, and that essentially allows CALDERA to piece things together on the fly. As
Oh, I see. That's awesome.
So it's a lot more flexible that way.
Okay, cool.
Next slide.
Yep.
Yep. So sequences and chains of techniques are important to test because they best represent how attackers behave. Some methods of detection work based on how an adversary stitches together actions. Since a lot of those actions may be seen through normal use of a network, it's often hard to distinguish what's bad from what isn't without the right stimulus, testing, and intelligence. Getting as close to the realistic behavior as possible is, of course, one of our main goals with CALDERA. It'll never really likely replace human-driven red teaming or adversary emulation because there's a lot of nuances and problem solving that's necessary there. But it can closely represent certain actions that provide a capability to those who don't have access to red teaming or are just getting started at learning offense and trying to figure out how things work together. But what makes CALDERA interesting is how it deals with uncertainty. So most planning applications use full knowledge of an environment to plan. So one example is that heavily uses planning is robotics for motion. But in CALDERA, there may be multiple ways for you to approximate what credentials are on a system, but until it actually dumps them, it won't know what it gets until it does it, essentially, which is a difficult problem to plan over. And the way that we've implemented the system, it sort of adds to Caldera's realism. Because knowledge is restricted with Caldera, it behaves much more like a real adversary would when they get access to a network. So oftentimes they'll bump around as they're looking for things of interest, systems, files that they might be interested in, but they don't know the shortest path to the goal right off, unless they have prior knowledge before they got there. So that's an interesting aspect of Caldera. But the implementation also leads to execution flexibility. So to your question earlier, Casey, so when Caldera needs to plan around certain things, it actually makes the test more flexible to different environments and conditions. So if it runs up against a potential block, then it'll attempt to plan around that and find the next best path.
That's awesome.
Yeah, it can also recover from certain situations, like if a system reboots or a process dies, if it has sufficient access at the time. One other benefit is that it also operates with zero prior knowledge of the environment. So the only things you need to really configure up front are the operations attack profile, so the techniques that you want it to use during the operation, and then what system to start on. So that's essentially patient zero, and then it does the techniques to discover what it's interested in and kind of moves from there. It also does cleanup, so any artifacts that are left behind, registry keys, files, running processes, are all cleaned up automatically, so it can bring the network to a clean state after it's done. So
that's
Caldera,
awesome.
yep. Yeah, so Caldera is just one of our contributions to a growing community of open source around testing, and we're always looking for new help to develop new techniques. The goal of the research, of course, is focusing on the planning system and the autonomy and automation. And we do what we can to increase technique coverage, but there's, of course, a lot to be done. I mean, you guys can move a lot faster with the Atomic Red team than we can because of the logic that we have to apply to each technique.
A lot more rigor to define the technique that Caldera is going to consume as opposed to the one-liners that we're creating.
Right.
Yeah.
Yeah, and I think having the machine readable format will help us a lot in pulling in the information.
Sure.
But there is, of course, additional work to be done.
So
that's
Blake,
awesome.
Could we expect feedback in the future, as you and the Caldera team keep adding more descriptions of that prologue and the inputs and outputs from an objective perspective? Is that something you see maybe fitting into that Atomic Red team structured format, so you understand, hey, I'm doing this in order to obtain credentials?
Yeah, I think it's an important aspect just to collect for each technique, because people need to understand sort of what the adversary needs to accomplish before they get to a certain point, and then what they get after that. So it's definitely useful.
That's awesome. Are there any ways to, and this is just a question I had as you were describing it, sort of constrain Caldera? Because I guess some people may worry like how what if I put this in a system and it sort of goes wild? Like, is there any guardrails I could put to make sure Caldera hits a boundary or something? Does that make sense? Or
Yeah, and that's built into the system. So in order for Caldera to run an operation, we have to install a Windows shim. Basically opts it into the operation, so that essentially acts as the guardrail.
That makes sense.
Caldera is not going to go beyond that bound.
Okay, that's perfect. Yeah, good to know. That's fantastic. Really
so
cool.
We should absolutely write an Atomic Red team test that installs that shim automatically, and then we will have created Skynet.
Yep.
Oh dear. That's awesome. Yeah, this is really exciting. I'm glad that this sounds really, really cool, Blake. I think it's a good way for people to, like you said, chain the techniques together, because the techniques don't ever happen in isolation. And this sort of gives you that simulated, that adversarial discovery and uncertainty that's introduced as a part of an attack, as far as timing and velocity and some of that probably as well too.
Yep. Yeah, there's been a lot of interest in applications for training. So running Caldera in a range to train new defenders, so they
That's awesome.
are more apt to look for that type of behavior that they would expect to get from a real adversary.
It's fantastic.
And so Caldera is an open source project. Go download it, try it out, give us feedback, help us grow the community if you want to develop new techniques. There's also a demo video listed on the GitHub site in case you're interested to see how it actually works. And then we've done a lot of documentation. There's a guide in there to describe how to implement a technique with an example that includes the logic as well.
I'll just bring it up here so people can see it real quick, Blake. So kind of what you were speaking to there. There's the demonstration, a couple of presentations as well. So cool. Well, I think, is there anything else, Blake, you want to add on that? Or want to give people a chance to ask Blake questions about Caldera, the automation, some of the things that he's describing there as well. So Mike, I'll turn it over to you if there's any questions in the queue specific to what Blake was describing.
Yeah, man. It's gotten a little loud over here, Casey, but I'll try to ask them. You guys hear me okay?
Yep.
Okay. So a couple questions for you, Blake. Kind of one of the top ones was, is there any more release date information for the attack ICS?
No, not at this time. I talked to the team a few weeks ago, and I know they're trying to work towards releasing an update to the matrix that I think was posted in a slide deck a few months ago, since that's relatively out of date. But I think they want to get like a full white paper together and release with it. So there will be an update coming. I just don't know when at this point.
Cool.
Cool. Yep. Awesome. And then the next one kind of below that was, and this is kind of for the atomic side, is once that does get released, Casey, what do you think like the turnaround would be for new techniques as far as what we would publish in the community?
Well, I think for us, our time is obviously constrained right now. It's basically been you and I and Adam and a couple other contributors and Tony from Red Canary side, but we've had good contributions from the community. So like as updates are pushed into the attack framework, it's as quickly as the community wants to go, right? I mean, as far as if like some things we can do very quickly, they lend themselves to writing a code. Maybe there's a proof of concept already published, but other techniques may take a little time to discover, unravel specific details and think through like, how would I actually write this as a test? So I don't have a real specific, like, a turnaround time is XYZ, but we can move as fast as you guys move. If you're contributing, if you see something posted, I think it's probably important to clarify that all of our tests and techniques tie back to the MITRE framework. So if there's something you see on Twitter, for example, we're probably not going to pull it into Atomic Red Team yet because we don't have a place to map it to a specific technique that people are testing. It doesn't mean it's not viable or a valid test. It just means we just want to let MITRE be the ones that create the taxonomy and describe that before we put a test in, if that makes sense. So, and that's been really quick. And I think there's a lot of people in the community contributing to Blake and his team to keep new techniques up to date as they see things in the field as well. So, and I know they've got a contributor's attribute associated with each technique to describe who contributed and also references for sources of a particular technique. So it's not just theoretical in some situations. These are actual attacks that have seen it, or there's a groups page that will describe a group that's using that technique. So I think that maybe, hopefully it gives you some answers to the question. So.
Yep, okay. Perfect. Then one question kind of for both teams here. So this comes from Roberto Rodriguez. And so the question is one thing he's working on, right, is related to creating data analytics around the attack technique, considering attack variations. So for example, what he has is disk versus memory variations of an attack that helps to measure the maturity of a data analytic. Are you guys planning on doing some type of categorization of the complexity of the attack?
I would probably defer that to Blake. I don't like, again, I think that would be an attribute that would be needed to be added in the framework. So I'll pitch that question to you, Blake, if that makes sense.
Yeah, I mean, one thing that we're planning on doing is implementing a sub-technique structure. So I think that might partially address what you're looking for. So there's a few techniques that are kind of very broad and have a lot of variations. So credential dumping, for instance, there's lots of ways to do it. So we wanted to formalize a structure around what the variations are for individual techniques. And I think that might help with some of the abstraction. So we might be able to create new techniques and roll things underneath that make sense in a logical structure. I don't know if that answers your question, but I think it'll actually help.
Cool. Yeah, I think for all the metadata from an atomic perspective, we're just pulling in the sources and attributes from MITRE. So just deflecting to them for those. Yep.
Yeah, we always try to turn it up to 11 on everything we do. So if it's not 11, we don't commit it. That's what I tell Casey.
Yep. Nice.
So next question we have is, so it's going to be, what is the difference between Atomic Red Team and Caldera, or is there a way to collaborate both tools?
I'll share my perspective, then maybe Blake can provide his perspective. But I think Atomic Red Team is an entry point, right? It's a place to start learning about techniques, demystify techniques, maybe run some initial basic testing. From what Blake described with Caldera, it's definitely a much more adversarial simulation capability. It has a different set of objectives, I think, than what we have from Atomic Red Team. It's definitely more mature as far as like capabilities for a test to self-discover and solve, like take inputs and outputs. So I guess we really see Atomic as a place to start. And we really wanted to bring Blake on with the Caldera to just showcase some of the work that some more mature teams may be ready to step into. I'll let you answer that, Blake. I don't want to speak for you, but that's I guess how I see some of the distinctions between the two projects.
Yeah, I think you pretty much nailed it. So I see Atomic Red Team as being very useful at generating representative data. And that could be very useful for a lot of people just to make sure they're collecting the right things. Whereas Caldera does replicate more of sort of that end-to-end adversary behavior after they've gotten access to the network.
Right.
So you're testing much different things, and it operates in a much different sort of autonomous way.
Yes, exactly. Cool. Good question.
And then as far as that was a great one. And then as far as what is included with Caldera today out of the box, like what does it come with, like all the techniques mapped out, or is it kind of specific just today?
Yeah, so it comes with the planning system and a set of techniques. I think there's about 30 or so that were released that cover, a fair degree of the tactics and attack. There's not a whole lot of variation yet. It's something that we're working on. We're hoping the community can help build out, because attack is pretty large at this point. So fully covering it in Caldera is difficult. It only works on Windows, so there isn't any compatibility for Mac or Linux at this point. And the planning system itself is somewhat limited, since it is a very difficult problem to solve algorithmically. You can really only run it on between 15 and 20 systems, which may be just fine for what you need to test various behavior, but you're not going to deploy it to an enterprise of 1,000 systems in its current form, because it'll just fall over.
Awesome. Cool.
Great. And yeah, the last one is running Caldera. Just run it on a VM. Does it require a lot of horsepower or anything like that? Is it pretty simple from that perspective?
Yeah, it's pretty simple. We run it on our laptops or VMs. It should run on 4 to 8 gigabytes of memory. We haven't really gone back to see what is the minimum set of requirements, but it isn't bad.
Perfect. Awesome. I think we're closing in on time here, so. I think if there's any
hundreds of people who want to know, what does Sub T eat for breakfast?
It's basically, I'm not going to disclose it on this webinar. I'm not going to go on the record. You have to buy me a beer if you want to find out, if you want to answer that question. So yeah, good times right there.
You're welcome.
Yeah, but I think one thing that I know we had probably several questions that we may not have answered, and so we want to follow up. We'll probably do a blog post to address some of the questions, but we really want to make sure we thank everybody for your time. I don't know, Mike, Blake, Brian, do you have any other closing thoughts or ideas before I shut this thing down? Anything you want to say?
Yeah, no, not for me. Just appreciate the invite to participate in this. It was pretty awesome.
Yeah, thanks for being with us. Really cool stuff you guys are doing, and we appreciate all the effort on both Attack and Caldera. Great stuff.
Yeah, thank you guys. Appreciate it, Blake.
All right. I'm going to shut it down. This is the end of the recording. Thanks, everybody, for your time. Have a good rest of your week. Feel free to, again, join the Slack community if you have specific questions or want to reach out to us. There's resources there for the Atomic Red team for Red Canary, and also the resource there for the Caldera project. So thanks again. Talk to you soon.
Right, thanks.
Bye.